finding the zeros of polynomials is the same as finding the zeros of quadratics, because quadratics are a type of polynomial. Now, we will get a little more sophisticated and talk a little bit about nuance of this in this discussion, but it starts the same way. So if we are looking at some number that when we plug it into the function, it gives us a 0. It gives us a value of 0. That is a 0 of the function. It is also an x-intercept. It is also can be written as a factor. X minus some number c is a factor of a polynomial. All of these things point to the same idea, that it is a 0 of the polynomial. Now, where this gets a little more interesting is when we think about all the factors of a polynomial. So if we have a polynomial, and it could be written in a factored form, something like x plus 2 times x minus 3 times x plus 1. That is a polynomial written in its factored form. In that form, it's very easy to see the zeros. -2, +3, -1. But one of the ways it gets a little more nuanced is when we start talking about something called multiplicity. So multiplicity is when you have zeros that are repeated. So if I were to add x plus 1 to that previous polynomial, there's a 0 of -2 that happens once, a 0 of +3 that happens twice. But the 0, -1 happens 2 times. It has a multiplicity of 2. So we would say that -1 is a 0 of multiplicity 2. Now, this matters in some regards and it doesn't matter in others. So if we're just talking about zeros, before I wrote this extra x plus 1, our zeros were -2, 3, and -1. After I add that x plus 1, those are still the only 3 numbers that give us a 0, that are an x-intercept. So in that regard, it doesn't matter. Where it does matter, though, is how those zeros are enacted. And what I mean by that is this. When we look at this picture right here, we see zeros. I see a 0 here, I see a 0 here, I see a 0 here, and I see a 0 here. When we talk about multiplicity, we generally categorize into 2 camps. Odd multiplicity. I gotta spell this out. Odd multiplicity and even multiplicity. Now, when I say odd multiplicity, I mean the same factor, x plus 1, x plus 1, x plus 1. I mean it happening an odd number of times. This has a 0 of -1, and that -1 has a multiplicity of 3. That is an odd multiplicity. Even multiplicity means the same 0 happening an even number of times, 2 times. Odd multiplicity, that would be like happening 1, 3, 5, 7, ... An even multiplicity would be like that multiplicity, that factor happening 2, 4, 6, 8, and so on. Now that we're talking about what it is, what's the difference graphically? And so what I want you to see is this. Odd multiplicity crosses the x-axis, crosses it. This 0 right here happened either 1, 3, 5, or 7 times, so on times. It crosses. It happened an odd multiplicity of times. This one happens an odd multiplicity of times. This one over here happens an odd multiplicity of times. But this one right here has an even multiplicity. It for sure touches the x-axis. It just touches. It doesn't cross. And we call this sometimes a bounce. It bounces off the x-axis, bounces off the axis. Now, why does that matter? It matters because in how these behave. So if you want an example to think about what what it really means to bounce off, think about the parabola. F of x equals x minus 1 squared. Now, x minus 1 squared has an inferred plus 0 right there. But that means that we take one step to the right, and that's where our vertex is. And when our vertex is, in fact, right there, this parabola comes down and touches the x-axis, and it goes back up. So we'll say bounces. It was above, so coming down here, it was above, it hits the x-axis, but instead of crossing, it bounces back up. Now, in the context of this other picture here, it's going up, oh, it bounces and comes back down. So bounces can happen whether you're above the x-axis or below the x-axis, but it plays a lot into what's called in-game, how they behave at the extremities. And we will talk more about that in a later video. But multiplicity is something you pay attention to as it influences the behavior of the polynomial. And ultimately, zeros still have the same definition. It's where the x-axis, where the graph intercepts the x-axis, whether it touches or crosses it. It has a factor of x minus whatever the 0 is. And you can have things that happen 1, 2, or a whole bunch of times, factors that happen any number of times. And that does have consequences for how the graph will behave based on those zeros.